Okay, so basically it comes from um, power functions. Power functions we call them. Uh, that means x is available or visible as exponent. So you have a base and there is an exponent. So this is called a base. And if we write something like this, we call it as an exponent form. For example, in general, a to the power of m, b to the power of m, these are all in exponent form because you are writing something to the power of something else. Okay, but in the event we have a function, because we have done the differentiation, things like that, we know what's f of x, right? If f of x is any of these things, 2 to the power of x, 3 to the power of x, or 10 to the power of x, or 100 to the power of x, or e to the power of x, okay, all these are exponential functions. So how, that means each of them can be, we can graph them, and we can see the how the graph looks like. Okay, so any function can be graphed and we can see if you put x equal to 0 for any one of them, right? So at x equal to 0, 2 to the power of 0 equal to 1, 3 to the power of 0 equal to 1, 100 to the power of 0 equal to 1, and then e to the power of 0 equal to 1. So what it means is, so you have at 0 value, everything will go through this something called, yeah, that 1. Okay, all functions. So it can be 2 to the power of x. So if it is a 2 to the power of x, then when x equal to 1, this is equal to 2. This is a 2 to the power of x. So 3 to the power of x will also go through the same way, but then when x equal to 1, it's a 3. Yeah, this is 3 to the power of x. So all of these graphs will go through x, the y coordinate, and the y intercept is 1. Okay, so in other words, they have the y intercept as 1. Y intercept is 1. Also another observation is that they are all, positive functions. Okay, these are called positive functions, rather positive valued functions. That means you always have a positive value only, you don't see a negative value which is below x-axis. Okay, all of them are above the x-axis. Okay, so that's why in reality, like most of the natural things, like you'll have some positive valued function. Okay, real valued, also positive valued functions. Okay, so why do we need this kind of a background? Are we talking more about this logarithms? So I'll just quickly move over to the logarithm, exponent and logarithms. First I'll explain without the x function there, then we'll come back. Okay, logarithms actually the way they started, okay, to ease the multiplication and division process. So they started almost many centuries back. Okay, so when there were no calculators, nothing, so they had something, some mechanism to convert. For example, you have for example 10 to the power of 21 multiplied by 10 to the power of 7. Okay, this is easy, we learned in indices. We do a to the power of m plus n, we say 21 plus 7, that's 10 to the power of 28, which means 10 followed by 28 zeros. It's a huge number, it's a huge number. Okay, so this is fine if you have the base is 10. For example, I have 2 to the power of 6 multiplied by 3 to the power of 7. So the base is not same, I can't multiply and use them, so the indices rules won't help here. So if you really were to actually multiply, then 2 to the power of 6 is nothing but 64, and 3 to the power of 7 is really huge number. You'll have to see how much 3 to the power of 7. Okay, so it's a longer process to, I mean, with calculator it's easy anyway. Okay, so before the advent of calculators, what they used to do was they used to convert each of these exponent forms into logarithm form, and that's how logarithms actually came in picture. So let's look at the simplest way to understand this. We already said anything to the power of 0 equal to 1, 10 to the power of 0 equal to 1. 10 to the power of 1 is 10. 10 to the power of 2 is 100. Okay, so what it's coming out to be is, if I am worried about only 10 to the base is 10. Okay, so then they write with a notation log, okay, of this log 1. So whatever on the right side, right, and base, will put this base, log of this 1, this is the value, yeah, log of the 1 to the base 10 equal to 0. Okay, how do we read that? As log of 1 to the base 10 is 0. Okay, in fact, so that is how it's conversion. That means you see whichever is the base here has taken position here. Whatever is on the top right, that's the one it's actually going to the right side. So yeah, we converted now a exponent into a logarithm. Okay, so what this means, this rule is applicable for anything and everything. Meaning, if your base is something else, for example, I have 2 to the power of 4. This is in exponent form. So 2 to the power of 4 is 16. If I write this in a logarithmic form, the base has to be coming, so log 16 to the base 2 equal to 4. This is a logarithmic form. Okay, so how they were trying to use this, if I have 2 to the power of 4 multiplied by 2 to the power of 8, I know that I'll get 2 to the power of 12. So how they do in this logarithmic form is 2 to the power of 4 is log 16. Okay, 2 to the power of 4 we wrote as log 16 to the base 2, right? Correct? And then they add up log, this one is 2 to the power of 8. Okay, this is nothing but log 8. So log 16 is 4, log 8 is 3. Confused? Confused, right? Okay, yeah, I'll go backwards. So we have used the exponent rules. We say 2 to the power of 4 plus 8 equal to 12. So log 16, we have written this as this, and the next one 2 to the power of 8 as log, actually 2 to the power of 8 is 256. So 256 to the base 2 is 8. So how do I got 256? I actually did 2 to the power of 8. 2 to the power of 8 is 256. Afterwards, now I am telling actually. So you simply add whatever is on that right side, right? 4 plus 8. You get 12. Okay. So the 12 you are already getting by adding this onto the right side. So this is actually nothing new, since we know these rules because we are adding the exponents, and that's what is applied in the logarithmic form also. Okay, actually, as long as you know the exponent rules very well, adding is this, then the logarithm rules will follow now. Okay, how they follow? If you have a to the power of m into a to the power of n, the base is same. You have in the exponent form, it is a to the power of m plus n. So in the logarithmic equivalent is, you have a log mn. If you want to multiply two numbers, you just take logarithm of first and you take the logarithm of second, add them up. Okay, so if I have a to the power of m divided by a to the power of n, I get a to the power of m minus n. So that gives us equivalent is log m over n is log m minus log n. So you are wondering, like, where is this base gone? Yeah, of course it is here. It's here. Okay, the base is there. Okay, the base is there. Okay, so a to the power of m and whole to the power of n, we used to get this as a to the power of mn. In this case, there is a difference here. Log m to the base n to the is converted this like this. It will come as n log m to the base n. Okay, this is the only thing you need to be remembering. Is, of course, these things are available in your booklet. Okay, these formulae are available. This right side, whatever I have given on the right side, is important to understand. These are the logarithmic fundamentals. Yeah, these things. So let's look at something, and there is one more. The rules will be actually, if I have log 1 to the base anything, any base is 0. Log to base anything, any base is 0, and log of 1 to the base anything, 100,000 or whatever, equal to 0. This is what we have seen in a couple of pages back, right? Okay, and log anything, here anything meaning this fellow should be greater than 0. You cannot have a something less than 0. That means for negative numbers we don't have a logarithm. So log anything to the base of anything means both are same. For example, if both are same, that answer is 1. Log 20 to the base 20 equal to 1. Log 100 to the base 100 equal to 1. Log x to the base x equal to 1. Whatever is x value. Okay, so we understood when the 0 will come. We understood when 1 will come. Okay, all right. So negatives also will come, but there is no log of negative. Log of negative not exists, not defined. Okay, not defined. Yeah, you can't have a negative number here. Okay. Huh. F of x can be negative. It can be negative. Okay. See, f of x meaning, when we say f of x, right, its value is varying, right? So if I say, for example, minus 2x, this is positive when x is negative. Got it, right? But it is negative when x is positive, right? So this is not defined, log not defined for this. Got it, right? Yeah. So now coming back to log negative, these are all the important things to remember, short things. Log negative not defined. And then you have one more. If I have log 10 to the base 10, I said 1. Okay. What is log 1 by 10 to the base 10? Okay. So that means we are trying to see if you have a reciprocal here. See, this part is a reciprocal to this. Then you get minus 1. How we get this is, we are applying the rule, since this is nothing but log 1 minus log 10. It's m by n, right? We did that rule here, m by n. Okay. So log 1, that is m, this is m, and this is n, log 10. So log 1 is 0 and log 10 is 1, and that's why you got minus 1. Understood, right? So, but don't get confused, meaning, for example, I have log 100 base 10, it's actually, its value is 2. 2. How do I get it? Because 10 square, right? 10 square is 100, like that. Okay. Yeah, like that. Okay. So you will automatically remember these things, very easy. And if I were to have log 1 by 100, the answer, would that be minus 1 or minus 2? Which one is correct? Correct. Good. This is the correct answer. So the reciprocal of that automatically will have a negative value. Okay. Reciprocal in exponent form. In exponent form will give you negative in a logarithm form. Okay, these are little things which would be, better to remember rather than trying to do with the calculator at the time, get surprised and all. Okay. So now another important thing is, as we said, base can be anything. There is something called a natural logarithm. That is when the base is e. E has a value 2.718 or something like that. Okay. So you do not need to bother about how they got into this value. But when they don't mention anything, if they just write log, the moment they write just log x, this actually means this is log x to the base e. Okay, the base is e. Okay, and this is pronounced as read as ln x, and they write that as like this, ln x. Okay, ln, and then it will be read as ln x. Okay, because when you talk to teacher or someone else, the other people will be like seniors, they'll be asking, oh, that is ln x. Okay, ln x, like that. Okay, they won't read it as ln x. Okay, so these are the little fundamentals what we have gone through, both exponents and logarithms. So how do we need them, and when do we, whether we can plot them? Yeah, we can plot them. Okay, so if I look at the graphs of them, okay, so let's look at how 10 to the power of x looks like. Yeah, this is the graph part of it. Okay, so this goes to the 1, and when x equal to 1 you'll have value 10. So when x equal to 2 you'll have value of 100. See the difference between this and this. Okay, so the graph will go like that, like that, like that. Okay, I think let me correct a little bit. So x equal to 2, this is 100, this is this. So it will be going through them like that. Okay, so whereas I have a similar thing, that means y is equal to 10 to the power of x. If I have to have some function, okay, a log x, log something, log y to the base 10, that's equal to x. Okay, so if I convert this into a function, that means a log function. Yeah, a log function will generally be like this. So wait a minute, not correct, not correct, sorry. So log 0, okay, we said log 0, right? It doesn't exist. But yeah, but any one, for example, you have this is a log x. X has to be greater than 0. That means if I have 1, so it's a 0. If I have log 2, okay, then it could be some other value. Log 3 can be some other value. Okay, so like that it goes. This is a logarithmic function. Okay, yeah. Now let's now move back after the graphing part of it is done. Where do we use it? How do we use it? And how do we simplify things, logarithms? We will work out now. Okay, if you have a question? Okay, so few examples. Log 256 multiplied by 2. So this is what we have, for example, and the base is 2. So we are applying the rule log 256 to the base 2 plus log 250 log 2 to the base 2. Yeah, so this is log m into n. So m is 256, n is 2. So you split them, log 256 and log 2 separately. Because the answer is log m plus n. For this, log m plus log n. This is this rule. Okay. So now, how for this particular thing, next step is these two are same. That means this value is 1. 1. If base and this are same, then you have the value as 1. How do we get the value of this? So we will write 256 in the powers of 2. You can write this as 2 to the power of 8. So then again applying the rule, log m to the power of n will give you log n log m. This will come to the front. So we'll get 8 log 2 to the base 2 plus 1. This 8 will come to the front. This 1 is this one. Okay. So now again these two are same base on this. So we'll get 8 plus 1. 8 into 1. That's 8 plus 1. So we got 8 plus 1. which is 9. So this is, we actually evaluated log value of that. Okay, if I have log 256 into 2, and that's how I will write it. Understood, right? So let's look at the other way around. If I have a reverse of this, these are the log fundamentals I'm teaching. Okay, so you don't have any copy of the textbook, right? I'm sure this is the first exercise. Yeah, that's why. No, that's why. Yeah, yeah. So let's go to the next part of it. I'm sure these are there anyway. So I give the other way, saying log 256 base 2 plus log 4 to the base 2 equal to how much? So this is the reverse application of the formula. That means it is given as a log m plus log n, of course, to the base 2. So this gives you log mn to the base 2. You are seeing the addition here, that will be resulting into the multiplication. Therefore, this can be written as log base is same thing 256 into 4. That's equal to log 1024 to the base 2. So you multiply this, mn is nothing but this. So we try to see the multiplication in the exponent notation has become an addition in the log notation. Okay, so you have log of the product. Okay, so it was actually addition here. This addition has turned out into a multiplication. Okay, so it can be, yeah, it can be with any other base also. Let us look at with another base. So you have log 27 to the base 3 into 9. So which actually, if you multiply them, 9 sevens are 63, 9 twos are 18 plus 6 to 43, log 243 to the base 3. So yeah, so this is the first method I am doing, method 1. Then I would better write this 243 in terms of 3. That means 3 times 3 is 9, 9 times 3 is 27, 27 3 is 81, 81 3 is 243. Yeah, I'm in terms of base. Okay, yeah, I'm writing this in terms of base. So then I get log 3 to the power of 5 to the base 3 to the base 3, right? Then this thing will become 5 will come to the front, log 3 to the base 3, which is 5 into 1. You got the answer as 5. So we will do the same thing with the method 2, log 27 to the base 3 plus log 9 to the base 3. And I write 27 as 3 cube plus log 3 square to the base 3. So this 3 will come to the front, 3 log 3 to the base 3 plus 2 log 3 to the base 3. So this value is 1, therefore I have 3 plus 2, that's equal to 5. See, it's 5, same value. Yeah, so there, if you look at the calculator, when they are giving as a base or whatever, right? If the base is given as a choice, yes, you can like 2 or 3 or 5, then you can type it. Okay. You see on the screen of on the keyboard, right, on the keypad, you'll have log. Okay. So for example, I'll give you a value, type it, and what the calculator shows. You just say you press log button on the calculator and give 2. How much you get? Yeah, correct. 0.3010. Okay. This is a log2 value. So this here the base is assumed to be log 2 to the base 10. The base is assumed to be 10. Okay. And then you must have another function ln is there. Do you see that also on the keypad? On the calculator. Oh, there is another log button. Press that and then give. Ah, correct. That's what. That there you can choose the base also. Okay. Got it, right? Yeah. So you have, yeah, you can actually choose any of those and then. So that's how you get from the calculator all those things. Okay. So with the calculator it's easy. You multiply and all the things. The rules, like in case you don't have, you are not supposed to use a calculator, then we are talking about the rules. Okay. So now for example, they ask you to say log x to the base 10 equal to 5. What do you think the x value will be? Not multiply. You take this as a base. That means you put like that. Then this as a head. It will come onto the head. So whatever is the value, you probably get 100,000, right? That's the value of x. X equal to 100,000. Right. So I think you can use the calculator now. Let me give you a few more questions like that. Okay. So log x to the base 2 to the power of 5. Sorry, equal to 5. So what's x value? 32. Correct. Good. That's correct. Okay. So let me give another one. Okay. Log 32 to the base x equal to 5. You still will have to do like this is a base, right? So x to the power of 5 is 32. So x equal to 32 to the power of 1 by 5. Right? Okay. Next, let me give another question. Log 343 to the base 7 is how much? Good. So x equal to 3. So another question. I keep moving off that x value to different things, and we'll practice it. Log x log 1000 to the base 10 equal to x. Base is 1000. You can try, you can use a calculator and see what value you get. So x equal to 1 by 3. Correct. So, and let's try log minus 10 to the base 2. What do you get? You should get an error. Math error. Okay? Math error. Yeah. And let's do now the other way around. Log 2 to the base minus 10. What do you get? Same. Math error. So what do we infer from here? These fellows, right, cannot be negative. Okay. Now, having confirmed that, let's consider now log x to the base 100 is minus 1. So 0.01, right? 1 by 100. Yeah, correct. Okay. So this can be negative. Yeah, yeah, like that. Okay. So you change this value from minus 1 to minus 1.5 or whatever, x will become same. It will be changed. Automatically x will be changed. Okay. Okay. Now let's look at another type of questions. Log x equal to 100. Log y equal to 200. I want log xy. Yeah, you can. You tell me base. I can. E. Yeah, yeah, it's E. Okay, but you can take it as 2 also, not a problem. Okay. Yeah. So two answers I'll give you. I'll give you 20,000. I'll give you 300. Another one 100. Another one 200. The one 0. So you multiplied them 20,000. No. Log xy is nothing but log x plus log y. So it's 300. Okay. So this is how the questions, you based on the fundamentals. Okay. So questions could be like this. Okay. So again, there are certain pitfalls or whatever you can say. Log x is given 100. Same question. Okay. Log y is given 200. What's log x divided by log y? Definitely this is not equal to log x by y. Both are not same. Both are different. I know you would say that. So this answer is actually 100 over 200. So that's 0.5. This is the one. That is this rule. This is equal to log x minus log y. Yeah. Yeah. So now let's suppose I ask you to find out log 100 to the base of 200. How much do you get? 0.869 something like that. Correct, right? Yeah. So if it is the other way around, log 200 to the base 100. 1.15 or something like that. So you are seeing that also, like if the base, the actual number is less than base, or the base is less than this, how the numbers more than 1, less than 1, all these fractions. Yeah, that also you can actually play with this kind of a thing and understand or observe, how the variation will be. Okay. So we have done log x, log y, and whatever. So let's suppose another question comes and we say log 2 is 0.3010, which you already told me. Log 2 is 0.3010 for to the base 10. Okay. What's the value of log 1 by 4? Yeah, to the base 2. Wow. Quick. You said -2. Not correct. So it involves a couple of steps. So you try to write in this 1 by 4, right? In terms of this 2. That means we write this as log 1 by 2 whole squared to the base 2. Then, yeah, then the 2 will come into the front and you will have log half to the base 2. Then you apply this rule. If it is 2 and then 1 by 2, you will get negative of that, right? 2 into minus 0.3010, you should be getting minus 0.6020. So let me put this question in a different way now. Log x to the base 2 equal to minus 0.6020. Tell me the x value. No, 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 no. This you convert this, right? 2 to the power of this equal to x. Yeah, yeah, yeah. No, no. You should get 0.25. 65? How? Yeah, 2 to the power of. Okay. 0.65. So let's look at this calculator. I don't think I have powers here. 2 to the power of is not there. I don't have this actually. Yeah, this calculator is not. So we followed this, but we did 2 whatever. Okay. So how do we make sure that this is 2 to the power of something, then only we'll get it. Otherwise you have 2 to the power of minus 0.6020 equal to, you got as a 0.65. Is it 0.65? 0.65. Okay. So what I am trying to say is that if you have that 1 by 4, okay, if I have 1 by 4, 2 to the power of x equal to 1 by 4. Can you tell me what is the value? How did I do this, right? Okay. So yeah, I assumed this as x log 1 by 4 to the base 2 equal to x, and I converted in exponent form. I get 2 to the power of x equal to 1 by 4. This to the power of x. That's an exponent form. So this is what I am asking. Okay. So when I have 2 to the power of x equal to 1 by 4, then obviously we write this. I'm doing this in the next page. Okay. I got 2 to the power of x equal to 1 by 4. So how we did in exponents when we learned in earlier classes, we wrote this as 2 to the power of x equals to 1 by 2 square, and this fellow is 2 to the power of minus 2. So that gives 2 to the power of x equal to 2 to the power of minus 2. Therefore x equal to minus 2. Okay. Now let's go back and see. So I should be getting this value, okay, as minus 2. So this is where the mistake was. I'm just now trying to help you on this. How do we do in a hurry, and how do we land into the issue here? This is where the issue was. Okay. Why it was an issue? Because I just substituted this 0.3010. That is not this value, isn't it? 2, log 2, right? That's for log 2. Okay. Now I will do that same thing here. I'll do that again. Okay. You had log 1 by 4 to the base 2. Then we have written this as log the base 2 1 by 2 whole squared. Then we wrote this as this 2 comes in the front. So we wrote this as 2 log 1 by 2 to the base 2. Correct? Then we take this 2 and we have to put a bracket here. Log 1 to the base 2, this is m by n, minus log 2 to the base 2. Because m by n, log m minus log n. So log 1 is 0. Log 2 to the base 2 is minus 1. Understood, right? So the 0.3010 won't come into picture at all. Yeah. Okay. Because this is a different base. Yeah, two different bases. Exactly. Understood, right? Mm. Okay. This base is different. So the moment you substitute that without looking at, then you will have an issue there. right? So that's how either way you do. This is in a we try to solve this in a exponent form, exponent solution. This is a logarithmic solution. Okay. So in the logarithmic solution, we don't do this power and all. We directly do the log rules. Okay. Okay. Now let me give another question. I still take that actually log 2 to the base 10 equal to 0.3010. I'll be asking log 1 by 2 to the base 10 is how much? Good, minus 0.3010. This is where the reciprocal come into picture. Then for example, you have log 1 by 4 to the base 10. Correct. Okay. So I'm just trying to see it. Now its a base is same. Yeah, base is same, so you are substituting that value. Okay. And so log 2 is given. Let's suppose log 3 is given. That's a 0.4771. Okay. And I ask, for example, what's the value of log 6 to the base 10? Hmm. 7, yeah, 781, right? 781. Correct. Good. So we are adding up. We have to add these values. So you'll get 0.3010 plus 0.4771. That's equal to 0.7787. Right? 771. So it's 871. 7781. Yeah. So what will be the value of log 1.5? Yeah. So you subtract them. Hmm. 0.17666. Yeah, correct. Okay. Yeah. Subtract. Yes. Yes. Okay. So this is what the general fundamental. I think will not rush too much because let them start. Okay. Let them start. You already started with this, is it? Yeah. Yeah. No, we are still far off from the book exercise, textbook exercise, and the board questions wise. Okay, we are still a little far off, but I don't want to rush and then see the way he will tell tomorrow. He will he will go to this topic within the first 15 minutes actually. He will actually cut short a lot of things, and he will straight away, if I am not wrong, he will straight away go with that m by n mn formula directly. Yeah, and then you may get confused. Yeah. Okay. So yeah, that's the reason I have just linked up to the exponents. Okay, and I made sure that you know how to maneuver. Okay, your path. Okay, in case of confusion. Okay. So actually they used to be like lookup tables, like log tables, like these are the things we have memorized because we were, in fact, when we were at your age, right, we didn't have calculator. Okay, so we were supposed to use the tables. So we refer something called, you'll have 2.0123. Under this value was given in that booklet. Okay, we used to take that value, and for 3 again there will be another value, so we used to add them. Okay, all this procedure we used to do. Okay, so now of course the problem is these were developed so many centuries back, And so lot of physics, chemistry, economics, mathematical models, they were based on the logarithms. So that's the reason everyone must learn that. Okay, so these are there into the economics, probability, chemistry, physics, because those days whatever research, whatever they found in those days, they were using this logarithmic functions, logarithmic values and things like that. Okay, and hence it won't go away from our education system. So everyone must learn that. Okay, so if he starts, I think, logarithmic functions tomorrow, and then plotting of the functions and going up to that will be great, but I doubt. Okay, I doubt he would do that. Okay, as per the syllabus, it is only up to finding the x value, and then you may get a quadratic also, getting the quadratic and solving that quadratic. All that stuff are a part of your syllabus. We'll cover on Wednesday. Okay, more things we'll cover on Wednesday. Yeah. All right. Okay. So yeah, no problem. Bye.